I'm going to introduce you to this new concept called an embedded system. What you see on the screen right now are two things. One's called a general purpose PC. This is what you guys use all the time, like laptops, for example, or a desktop computer. Some of you might not know what a desktop computer is. They kind of look like where you've got this tower, etc., and it's like a gaming PC, basically. An embedded system is different. An embedded system is completely different to a general purpose PC. But how is it different to a general purpose PC? Well, a general purpose PC, like a gaming PC, or your school laptop, can do a whole range of different tasks. You can play games, you can do your work on it, you could stream, you can do video editing, which is what I'm doing now. You can handle loads of different things, and that's because of the processor inside of it. The processor and the software, like Microsoft Windows, and all the apps I can put onto it, allow me to do that wide range of tasks. And that all what makes up a general purpose computer. We then have the embedded system. Both a general purpose computer has a CPU, as does an embedded system, which is right here. They both have CPUs, but there's a difference. The embedded system CPU is really simple. It's got a brain, but it can only do simple functions that it's been told to do. Whereas a general purpose PC's CPU can do lots and lots of different things. It's way more powerful. So how does an embedded system actually work, and what it's all about? This is a calculator. This calculator is an embedded system. The way this calculator works, it's got this microprocessor. But not only has it got this microprocessor, which I've just highlighted to you, it also is made up of different hardware and different software. So even this calculator has some software. It has hardware such as transistors. It's got hardware such as the keypad, where you can type in things. It's got LEDs. So it's basically a mini computer. And this mini computer system is really efficient. It does its job well. In this situation, a calculator does the job well being a calculator. The screen displays, the touchpad works with the CPU, the microprocessor. They all work together to perform simple tasks like addition, subtraction. So this is an example of an embedded system. Here's another one where we've got a washing machine. Inside this washing machine, or should I say the roll of this washing machine, we've got a screen. This screen will display to the person how long there's left of the cycle. You've also got inside the washing machine options to change the program. So you might have whites only, you might have a delicate wash. So it allows to change what sort of wash you want. Also, what we have inside the washing machine is a drum. The speed of that drum is controlled by an actuator. Now all of this is controlled by the CPU, the microprocessor. That microprocessor is responsible for displaying something on the screen. It's responsible for knowing what program you put the washing on. It's responsible for changing the speed of a drum. It's responsible for going beep, beep when it's finished. It is only job to do with a washing machine. If you were to put this microprocessor into like a normal computer, it just won't work. If you try to put it into a general purpose computer, the microprocessor is not powerful enough. But it's more than powerful enough for a washing machine because it's made for that washing machine. The code on it has been made for these tasks. So again, these are different types of embedded machines or embedded systems I'm going to talk about. You've got calculators, you've got washing machines, but they're more than just those two. We could also talk about other things such as like a microwave. A microwave is an example of an embedded system. Air conditioning units are an embedded system. They have a machine or a computer system built within a system, machine. Security camera, you've got a device like a security camera inside of it, you've got an embedded system, a computer within it. So all of these are embedded systems. A vending machine, that is a machine with what's inside of it, a computer system. So if I draw out a vending machine right now, you've got like Coca-Cola, you've got like Fanta, you've got Diet Coke, you've got Dr. Pepper, you've got 7-Up. Now, in a vending machine, you normally would have an extra little panel here where you would simply have a screen, maybe. You would have a keypad with coordinates on it and letters like A, B, C, 1, 2, 3, 4, so you can put the coordinates in. You have a slot to put your money in. The microprocessor inside of this vending machine is responsible for the brain part. It's responsible for sensing that you put money in and counting the amount of money you put in. It's responsible for displaying on the screen what's the drink you want. It's responsible for having the coordinates of where you want to fetch a drink, i.e. if you want a Coke, it might be in slot A1. It's responsible for dropping that drink into the collection unit and having a sensor to tell you or tell the machine it's been picked up. So all of these things make up the embedded system, but also it's going to have things like RAM inside of it as well, and it's going to have some software. And that all makes up our embedded system. The microprocessor is basic. It performs specific functions. Here are some characteristics of an embedded machine. An embedded machine performs specific jobs, specific functions, such as be a vending machine, such as be a washing machine. And it does it within a larger system. What I mean by that is this vending machine is a big system with lots of things going on. The embedded aspect is what's inside of it. Another characteristic of an embedded system is it takes up less power consumption. Why? Because a microprocessor is a lot more basic. So CPU in my PC, if I'm gaming or doing video editing like I'm doing now, it'll be working very heavily alongside my RAM. Because of that, my fans are going to be going in overdrive to cool it down. When my fans are working, it's going to take up electricity. Electricity will cost me dollars. A vending machine actually costs less to run, even though it's a bigger device, because a microprocessor, or you could argue that the drinks need to be chilled constantly, sure, but if you're talking about the microprocessor, it takes up less power for that to run. It's more reliable than a general purpose computer having embedded systems. That's because it does specific jobs. It does the tasks which it's been made to do, whereas in general purpose, someone might come along and make a completely and utterly brand new app. This app may have bugs in it, or may not work properly with your hardware. That may create crashes and system failures. And that's the risk of a general purpose computer. It does so many things, it's impossible for it to do all of those things perfectly. It's just not going to happen. Whereas with embedded systems, it's made for those tasks and those tasks only, so it becomes amazing at those tasks. My washing machine is amazing at washing. It's not going to have like bugs in the code because it's been made just to do that. Another characteristic is that it does not actually look like a computer in the first place. You wouldn't be able to tell sometimes that it is using an embedded system. So it may not have a screen, it may not have a keyboard. So let's have a look at this really old air conditioning unit. You can see it's got no screen, but it does have some buttons, and it does have like a dial. Inside of that, it will have like RAM, it would have like a basic microprocessor. So it is an embedded machine, but microprocessor is the thinking part. Keep that in mind, it's the brain. We could also say that it has, I've mentioned this already, limited processing power. It's a much simpler chip than what you'll find inside your school laptop. It also will have less memory, less RAM. So inside my gaming PC, I've got 16 gigabytes of RAM. You'll be lucky to find like a gig of RAM inside a embedded machine. It's just got less expensive parts because it doesn't need it. We could say that embedded systems are there to help control the system, such as like an air conditioning unit turning it on and off, to help monitor a system, like again with an aircon unit, to monitor the temperature, to assist different machinery. So think of any machine where a drink pops out. So embedded systems have their characteristics, which is what I've just mentioned. What I'm going to show you now is an example of different types of embedded systems. But keep remembering, it is a microprocessor which works with software. Like, it will have its own software operating system, be very basic, and its own hardware, whether it's basic RAM, a keyboard. So take a look at all of these. These are different embedded systems. Devices with a computer system built into it. So this GPS, for example, has an embedded system built into it. The embedded system will be responsible for things such as displaying the map on the screen. That'll be one of its responsibilities. It'll be responsible for things such as calculating the routes. It'll be responsible for the touchscreen aspect. So this device, you can touch the screen and it does something. And part of that will be the microprocessor, working with its software and the hardware. It's a machine, or should I say computer system, within this device. That is the embedded system. Traffic lights, it's got, again, a microprocessor within it. It's got its hardware, it's got like the lights themselves, which are outputs. It's got its own memory, its own RAM, and it works with signals. So it's a computer system within that device of a traffic light. So, pause this video, give it a go yourself first. See if you can solve this question. Alright, so Gav SatNav contains an embedded system. What is meant by an embedded system in the first place? Well, an embedded system is a computer system. And a computer system is when we've got RAM working with a CPU and you've got inputs and outputs, etc. So, an embedded system is a computer system that is built into another, wait for it, device. And you could also say it then performs specific functions or functionality. So again, going back to this washing machine analogy, you've got your microprocessor, which is the brains. You're going to have the software, which is all the different code, all the different things a washing machine can do. You're going to have an actuator, which controls the drum. You're going to have also RAM, which stores what program you're currently running, what job, like delicates or whites, that'll be stored in the RAM. You have ROM, which loads up the washing machine, and all of those are within that bigger device. They're built into it. So it's a computer system made for a specific role, built into this bigger device.